Hi, welcome to video 9 on differentiation, looking at sketching curves. In this video we're going to put together a couple of skills we already have to sketch a curve essentially, using a couple of different things we've done before, either at National 5 or earlier on in the differentiation topic. Okay, so this learning intention will be able to use sketch a curve, be able to sketch a curve showing where it intercepts each axis and the stationary points. Okay, so there's 4 things we want to be able to do here. Find where the curve cuts the y-axis. Okay, and you know that on the y-axis, x is always 0. Be able to find where a curve cuts the x-axis, and you know on the x-axis that y, or f of x, is always 0. Being able to find stationary points in their natures, and then one part that we've done before with other curves, but it'll just be a little bit more complicated here, is being able to put all that information together and sketch the actual curve. Okay, so we're just going to do one example again. It's going to run over several slides. But we're going to find the y-intercepts, find the x-intercepts, and find the stationary points. So for this curve here, this f of x, we're going to do each of those things. Okay, so firstly, I like giving myself lots of little headings here because it is a really, really long question, lots and lots and lots of marks. First thing I'm going to do is nice and easy. I'm going to find where it cuts the y-axis. If it cuts the y-axis, we know when x is equal to 0. Okay, so if f of x is 2x cubed minus 3x squared, f of 0 is, sorry, that's rubbish. I'm just going to rub that wee bit out there, sorry about that. So f of 0 is going to be 2 times 0 cubed, 2 times 0 cubed minus 3 times 0 squared. We know that's going to be 0, so it cuts the y-axis when at the point 0, 0. Okay, then part 2, I'm going to find out it cuts the x-axis. In this case, I know it cuts the x-axis when y is 0 or f of x is equal to 0. So we take 2x cubed minus 3x squared and we set it to 0. Two different powers of x, so we know it needs to be factorised. Luckily, we've got a common factor, so x squared is your common factor, and then you have 2x minus 3 left in the bracket, which means if x squared is 0, that means x is 0, and if 2x minus 3 is 0, that means x is equal to 3 over 2. So, two places where it cuts the x-axis, 0, 0, that's good because we already found that, and 3 over 2 is 0. Okay, so now we've got the y-axis, we've got the x-axis, now we're looking for stationary points. Okay, and we know that stationary points occur when, in this case, f dash x equals 0. Okay, so that's what we're solving next, f dash x equals 0. So f dash x, we know here is 6x squared minus 6x. We know that's equal to 0. Again, we've got to solve an equation as a common factor of 6x, which is x minus 1 equals 0, which means x is 0 and x is 1. We now have to look for the y coordinates for that. So when x is 0, f of 0, we've already done is 0. F of 1 is 2 times 1 cubed minus 3 times 1 squared. Remember, it's always going into the original equation to get your y coordinates. So it's minus 1. Okay, so my stationary points again are 0, 0 and 1 minus 1. Okay, and now we need to find their natures, and this is going to be very useful here because it's going to show us the shape of the graph. Okay, so for our natures, we want to know what's happening as you come up to 0, as you come up to 1, and as you leave 1. Okay, so those are my x values. We want to know what's happening with the slope, the gradient, so we're going to check the differential. Okay, let's pick values. Minus 1 before 0. In between, we're going to have to pick a fraction. Let's pick a half. And leaving 1, let's just pick 2. So f dash negative 1 is 6 times minus 1 squared minus 6 times minus 1. Okay, so that's 6 add 6 is 12. That means it's going up the way there. We know it's 0, it's a stationary point, so it's straight across. F dash a half is 6 times a half squared minus 6 times a half. So that's 6 quarters or 3 halves. Take away 6 halves, so it's negative 3 over 2. So negative 3 over 2 means it's negative and it's going down the way. That's a stationary point, so it's 0, so it's along. And then lastly, we're just going to do 2 quickly. So 6 times 2 squared minus 6 times 2. 24 take away 12 is 12. Okay, so it's going up the way. Okay, and then again, statement at the bottom. The first one's a maximum turning point at 0, 0. And then we have a minimum turning point at 1, minus 1. Okay, and now we've got to just put all that information onto a sketch. Okay, so firstly, we know the y-intercept is 0, 0. So roughly, I'm going to have my y-intercept at 0, 0 is just going to be at the origin. Okay, my x-intercept, my roots were at 0, 0 and 3 over 2. So roughly stick that on at 3 over 2. And then my stationary points were a maximum turning point at 0, 0. And then at 1 minus 1, it was a minimum turning point. So I'm going to look something like that. So putting my points on 0, 0, 3 over 2, and my stationary point is 0, 0, and another one down here somewhere. Now I'm going to have to apologise, it will end up being quite messy, it's quite tricky to do, but you're going to have a curve that comes up, turns at 0, 0, comes down here, and then goes through the point 3 halves and up and away. Okay, making sure you've got all your things annotated. So it cuts at 3, 2. The origins should be easy to see, so just leave that there at the origin. And this stationary point was 1 minus 1. Okay, so work your way through the information that you figured out, your y-intercept, your roots, and then your stationary point, and then just sketch the graph. Okay, lots of things going on here, lots of marks to fight for. So I especially, just a wee tip, I especially like my headings. So cuts the y-axis when x is 0, cuts the x-axis when f of x is equal to 0. The station points occur when f dash x equals 0. Do that, use a nature table, and then put it onto the sketch. Okay, so just revisiting the success criteria. Been able to find where the curve cuts the y-axis by setting x equals to 0, finding your y-intercept. Been able to find your roots, or where it cuts the x-axis by setting y equals 0, finding the station points and natures. And then the last bit, which will take a bit of practice, is being able to show all that information in a sketch of a curve. Thanks for listening. Bye.